Hello, welcome to the project update video for Team TBD9's CS7470 course project. The name of our project is Traffic Noise Frequency Assessment Application for Adverse Health Risks in Residential Property Occupants. This update video showcases our expected project outcomes, project plan, preliminary project results, and the problems that we have encountered while working on this project so far. Our group members are Syed Asad Zahidi, Sydney Cole, Juan Rodriguez, Yeping Yang, and Dante Barnes.
For the expected delivery outcome of this project, we intend to deliver an Android application which will allow users to press a button, record an audio clip, and be informed whether the road traffic noise at the location of the voice recording causes excess risk for ischemic heart disease, hypertension, or depression. This application will also have a landing page that informs the user how the application uses noise frequency to determine if traffic noise in an area causes health risks for these illnesses, and general information about how the application functions.
For the use case expected outcome of this project, we believe that residential real estate developers will be able to use our application to identify locations that regularly experience traffic noise at audio frequencies which pose excess health risks for nearby occupants of residential properties. The real estate developers can also determine if a new location needs to be considered for a real estate project if the planned location is determined by our application to pose excess health risks for the three illnesses that we are targeting in this project. For residential real estate occupants, this application will allow them to identify if a location that they are considering living in experiences traffic noise at audio frequencies that are a cause for concern for experiencing excess risks for any of the three illnesses that we are targeting and can inform their decision regarding the places that they consider living in. For the expected research outcome of this project, we aim to identify the audio frequency ranges at which traffic noise causes risks of contracting ischemic heart disease, hypertension, and depression for nearby residential property occupants. Through our research, we have also identified the Tarzos DSP pitch detection Java library as a good fit for helping us build the back end of our application. Since Tarzos DSP analyzes noise frequency in hertz, we will need to make sure that the frequency ranges that we identify which pose excess health risks for the three illnesses are measured in hertz or capable of being converted to hertz. For the expected development outcome of this project, on the user interface side, the application will have the ability to record audio from the default microphone of an Android phone using a button press. The user interface will also be able to store recorded audio as a MP3 file within the application. To be accessible to the back end, the user interface will also display the frequency of the recorded traffic noise and the illnesses that it matches, after these values are computed by the back end. On the back end side, the application will be able to access the audio clip that is recorded by the user interface. The backend will also be able to utilize the Tarzos DSP pitch detection Java library to compute the frequency of the noise in the audio clip in hertz. The backend will also be able to identify which illnesses the frequency of the recorded audio clip matches to and store this information for the user interface to display.
It isn't possible to include the entire detailed timeline from our project proposal in this project update without going over the time limit, so we have included the major checkpoints and their dates, which you can see on the screen. We are done with the first three checkpoints, except for the project update discussion. The research, the initial construction of the user interface, and the project update video are complete, and the project update discussion will be completed in the week following the due date of this project update video. The rest of the items that you see listed on the screen are not yet completed, but are on track to be completed by each of the dates shown next to them. Finalizing the back end, its integration with the user interface, which will also be finalized, testing, and final application build will be completed in the next 2 weeks. The project demo and the project report will be completed the week after that.
For our preliminary research results, we have been able to identify the ranges of traffic noise frequency values, which cause excess risk for contracting each of the illnesses that we are targeting in this project. For ischemic heart disease, the audio frequency needs to be between 950 Hz and 8,421 Hz. For hypertension, the audio frequency needs to be between 1900 Hz and 8,421 Hz. For depression, the audio frequency needs to be between 950 Hz and 2,105 Hz. These are the frequency ranges that the application will compare the frequency of the recorded traffic noise against and inform the user whether excess exposure to traffic noise at the location of the recording will pose adverse health risks for nearby residents matching any of the three illnesses.
For our preliminary development results, we have completed the research, initial construction of the user interface, the finalization of the project update video, and preparation for the project update discussion. We are on schedule to complete the project by the due date. We have encountered one problem during this project so far. Some team members were not able to push or pull code changes from the Georgia Tech Enterprise GitHub, which is what we're using to manage our code repository for this project in a command line environment without running into errors. We solved this issue by getting the team members who are experiencing it to use the GitHub desktop application for pulling and pushing code changes, and that is working fine.
And here is a list of all of the references which were used to create this presentation.